But all right, sweet. I can move faster now. Thank you to everybody who hung out. Those of you who just joined, I've been having some technical issues. So if I am fuzzy, make sure that YouTube has upgraded you. We are only on YouTube today because I had to rule things out, so I did that. Razor Sharp Bruce says, thank you, thank you. And we still have 50 people here, which is kind of amazing. There was definitely a huge drop, but we're back, which is great. Okay, so let's get started. After I shrink this window just a bit. Let's get started, even though we're a little bit late. Okay, so hello everyone. My name is Scott, and I go by Tannewt online. I'm paid by Adafruit to work on CircuitPython. Those are two things you may not know. So Adafruit is an open source hardware and software company based out of New York City. I work remotely, so I'm based in Seattle. This is my house. Welcome to my home. Up in the corner, you can see Spook, which is one of my two cats. I usually do this last, but I'll do it now. He is epileptic, so in case he has a seizure, I will stop and just make sure he's okay. He's been doing really well, so I don't expect it to happen. But I like to say that just in case. So that Adafruit does open source hardware and electronics, and I do CircuitPython for them. So CircuitPython is open source software that is bringing Python to little tiny computers called microcontrollers. And here's an example of one. This is called a Clue, and it's a microbit form factor board, and on the back it has a microcontroller, which is what? This tiny chip here, I think? No. I think it's the microcontroller itself is under, or no, it's on the, this is the microcontroller here underneath the lid there. So they're really tiny computers, and they're inexpensive, and they're really easy to get started. So I do these deep dive streams every Friday at 2 p.m. Pacific. I'm in Seattle. I do shift occasionally to Thursdays when I want to take Friday off, like I did last week, I think. Next week will also be on Friday, and next week is actually the 1-year anniversary of me regularly doing deep dives. So I haven't thought of anything to make it special, but it's special nonetheless. If you have ideas, let me know. We typically go to for 2 hours or more, and I'll take questions. I love to answer questions. I think Lady Ada is going to try and stop by, but there's never a promise of that. You know, she gets really busy. So if she does, she will. Otherwise, we'll just go and do things ourselves. And with that, I think that's all of housekeeping. Let me double check. If you want to chat with me and a lot of others, we have an Adafruit Discord server, which you can join by going to the URL adafru.it/discord. That's a great way, in case I'm trying to get the stream going, to chat with me, even if the streams aren't going. So thank you to everybody there for helping out, and also the patience while I got things going. So today, let me say hello to folks first. And if you have questions, now's a great time to put them in. And otherwise, we'll talk all about BLE. That's what we're going to talk about today. Although I think if Lady Ada does stop by, she may have some other stuff to show off. So thank you again to the 009 who gave the suggestion of turning off the GPU video compression, which is what made me all nice and smooth again. So hello there. I'm just going to start at the top. I said hello to Ram, but I'll say again. Hello, Daniel Chen, Johnny, Bruce, Pavre6, MD Roberts, Chris Komonos, Jason Kearsons. Hopefully these people are still here. Han Veckler, Sander Vesik. Everybody's recommending me reboot the internet. Bruce got a new electric bike. Jen Foxbot says someone unplug and plug back in the internet. Mr. Who says I had 0 FPS. We're through that, right? Gareth Coleman suggested a deep dive live podcast, which we could totally do. We could totally try that. Andrew Reed says hello from Cornwall. Ton says it's good. Yay. Everybody's saying hello. Hello, Sammy says hi, Adafruit. Dylan's just in time, had a minor rendering issue. David G says, am I late? No, your timing's perfect. Fede2 says, lovely afternoon, just came from a short walk on a park to pick up tree seeds. Ooh, that's exciting. Awesome. Hello, Jose David. Hello, DCD. What do I want the time code to be? So thank you again to DCD, who does take time codes. Just pick a time and just make them consistent, and then I can go back when I post it and shift them all. I'll cut all the start stuff so that it's not that bad. It was pretty bad, so we don't need that in the replay. I'll get rid of that. Hello, Microdev. Okay, and hugs again to the 009 for helping out. Congrats to Johnny Bergdahl for their first pull request. Also, and Mr. Certainly is going to make a mouse jiggler for the Apple TV. Ooh, perfect. Daniel Chen has a question, so let's go with that. Hey, Fred from Pittsburgh. Sammy says, I'm working on a digital thermometer for an old BMW that would obviously show the engine's temp. That's a good project. Okay, Daniel says, just started my first BLE project that I showed on Show and Tell. I'm confused what the BLE components I need to set up some kind of clear/reset connections and repair from scratch button to make my boards usable across devices without having to manually disconnect before reconnecting. You're going to have to tell me a bit more. I'm not entirely sure what you mean. That's certainly something that BLE has to deal with a lot, which is... oh, good. Congrats, Hamslab. Hamslab says, I just had an interview for a senior embedded dev position, and it seemed to go really well. Awesome. So... Daniel, I think with BLE, when it's reconnecting, the way in CircuitPython that I've done it, and I'll show this later, is that you basically have a while loop that runs and runs and runs and runs, and whenever a disconnect happens, it throws an exception. So it kind of goes to the top, and then that while loop kind of restarts from the start again. So yeah, BLE is really interesting. In terms of like getting it into advertising mode, like when in that while loop, I have it kind of like automatically revert to advertising. Oh, repair as in re-pair. Right now, when I plug in the battery, it auto connects to my laptop unless I first disconnect from the laptop. I'd like to have a button that just forgets connected devices and goes into pairing mode. Yeah, I think, in CircuitPython, there's a function you could call that says like delete all. Let me pull up the docs. Like you can delete all the pairing information from CircuitPython. Sammy, I see your question. I'll get to you next. So if we go down to core modules, BLE.io adapter, start advertising. So this is the thing that's under the hood. There's this erase bonding. So erase bonding will delete any previous information that on the CircuitPython side has been stored, but that doesn't necessarily mean that it's been, I know like on iOS, you also have to delete it from the iOS side as well. So I'll circle back to you. Let me address Sammy's question. Sammy says, I'm working on a digital thermometer, right, for the engine. I want to use an STM32, so what advice would you give me knowing that I'm really bad with programming? So I would, for folks who are new to programming, I would say use CircuitPython. I'm obviously biased because I work on that. But CircuitPython's really good for beginner programmers because it's very easy to read and it's pretty simple. I think what you want in terms of the technology for measuring the temperature of the engine is you probably want what's called a thermocouple, and people can correct me if this is a bad direction to go. But these are things that you see in like barbecue, like cooking sorts of applications. So a thermocouple is nice for a couple reasons. Is one, like there's usually like a pretty good distance of wire between where you measure the temperature and where you have like, oh, is the YouTube, I need to hit this button. Is that better? I have two YouTube chat windows open here. One that shows up on the stream and one that I do it. But yeah, that looks correct now. Thank you, Hugo. So yeah, I would say look at a thermocouple as a way to move the electronics away from the engine block. And so you can look here, and one thing you can do on Learn is if you find the product you want, but you want to know how to use it, usually you'll have links to the Learn guides at the bottom of the product page. So here you can see all the different Learn guides that are related to this product. And then the reverse is also true. So if you go to like a particular guide, you'll see feature products on the right-hand side. So folks are saying in the chat, usually modern engines try to keep the temp very stable. 190 seems right. You'd also want leads to, Ahmed says, you would also want leads depending on how far away the module is. Bruce is asking what year. Gareth Coleman says, for automotive applications, I would look for a specific engine temp gauge. Likely you'll need it embedded in a special nut or something. Daniel asks, does the car's OBD2 port give you that information? I'm kind of assuming that the car's old enough that it doesn't have it, but it's a 1989 E30. So I don't know if OBD was a thing at that point. Alvaro says, Fede2 says, yeah, thermocouple seems like the right sensor for this. Maybe an infrared camera if there's enough distance for the pixels to make sense. Or one of the 1 pixel IR thermal sensors. Bruce says it does have to be submerged in the coolant. Yeah, I don't know much about cars. So the folks in the chat here are a better resource than I am. DCD says, also look at RTD, using resistance for more precision if needed. Hugo says, 89, certainly no OBD. Hi, Tabletronics. You came in at a good point when my video is not like super framey and stuff. And no, OBD wasn't even an idea back then. I don't know my car technology. It could have been. All right. Any other questions we want to talk about before we get to Bluetooth stuff? ODB versus OBD. I don't know what I'm gonna mix the two up. Did you notice my I changed my background? There's my partner. This is just part of the background, but this is a hike we did last year. I was like getting kind of tired of the plain like dark theme of everything, so I had this pano from the hike, so I switched it. Yeah, Tabletronics, you missed the gunk. You're welcome, Sammy. OBD existed then, but OBD2 was 96 or so. Interesting. All right, let's talk BLE. We can answer more questions. I'm sure, like, I'm going to be surprised if we don't have any questions about BLE, given how much everyone wanted to talk about it next week. Okay, so what are we talking about BLE? Well, BLE is Bluetooth Low Energy. It is a version of the Bluetooth standard that they created in... Actually, I don't know what year it was, but Bluetooth 4 had BLE. And it's a version of the Bluetooth spec that was specifically designed for low energy, go figure. So there's kind of two version numbers you'll see. You'll see BLE 4, and then there's like up to, there's 4.0, 4.1, 4.2, and now there's 5.0 as well. One thing that's weird about BLE, so this is just kind of a BLE brain dump, is that BLE is, what was I going to say? It's not always advertised as Bluetooth Low Energy. There are some products that will say, was it BLE Smart, Bluetooth Smart? There's like some other brand for BLE that's different. And you do need to be aware of it because especially for like keyboards and mice, like Bluetooth 3 was actually really popular for keyboards and mice. So just because something says it's Bluetooth does not mean it's BLE. And so if you're looking for BLE things specifically, you have to be aware of that. So it's a wireless protocol that is really common from like a phone to headphones or mice and keyboards to a computer. Or if you have like, where's my tile? Like if you have like keys with a tile on it, this uses Bluetooth Low Energy to broadcast out information. If you've seen the COVID tracking stuff, there's an open standard or public standard from Apple and Google that is the exposure notification service for tracking proximity of people's phones for COVID exposure. So that is also an example of Bluetooth Low Energy. And BLE is kind of separated into two parts, two phases. I don't think I haven't covered any of this on the deep dive before. I was looking at a lot. I did a lot of this work, I think in 2019. Bluefruit. Bluefruit is a common brand that we use for our Bluetooth stuff. So this Circuit Playground Bluefruit was what we did a lot of work for. And I think it came out at the end of 2019, which is when I did a lot of this work. Yeah, so David is pointing out that BLE also uses the 2.4 gigahertz unlicensed band. So that's important. Hello, G3 Holiday. What David's pointing out is because it's wireless, there's a particular frequency range that it uses. And one thing that's important to note with BLE is that it shares a range with Wi-Fi. So one of the challenges with BLE and networking in general is that like it's never fully reliable. It's like always going to have some like you have to handle that you disconnect at any point. And if you're following CircuitPython, I actually had two different PRs already where I added some stuff where we weren't being super reliable. We weren't handling disconnects well. G3 Holiday, no worries, you're late. You missed about 15 minutes of me trying to get my video going, so it worked out. So yeah, the Circuit Playground is one of our core products here. And that's kind of when I did a lot of the BLE work. So we're just finally circling back to doing BLE. And if we did talk about the things that I wanted to do. We do every year in January, we do a planning cycle that we call like CircuitPython the next year. So CircuitPython 2021, for example. So the last, I think, 3 years, I've said I really want to do a BLE workflow, which is how do you use a CircuitPython device like this, the Circuit Playground Bluefruit, from your phone and only your phone, so that you don't need a computer at all. So, ooh, good question. Daniel Chen says, my Bluetooth computer dongle gets interference with the USB 3. That's interesting. So Jen asks, what applications would you recommend BLE for? I think there's I just found a really good chart. Let me find this chart. So there's a blog called the Interrupt blog, which people should follow if they don't. And then they have this monthly what we've been reading, and I just read over it. And there is a really good chart about different wireless technologies, which might be in this. Yeah, a look at the fragmented landscape of IoT connectivity. There's this really good chart, this chart here, which, let's see if I can make it bigger. There we go. And it's on the Twilio blog. So this is a great chart. And I know it's a little small, but this yellow box here is Bluetooth. So on the top axis, or the vertical axis, is range. So this is like how far do you need to talk. And then the x-axis is data throughput. So from bits per second up to megabits and gigabits per second. So what you find here is that like Bluetooth has smaller range than Wi-Fi, but like similar data throughput on the low end. Bluetooth Low Energy is going to be, I think, a similar range, but less data. So it's probably more down here by this thread box. But I like to use it for kind of two reasons. And that's because, so that's because there's kind of two pieces to Bluetooth Low Energy. There's a discovery part, which is like it's from one device advertising and then other devices listening to those advertisements. And that's kind of a like, I don't care who's out there, I'm just broadcasting something. Like the tile things, for example, just use that. Your exposure notification stuff uses that as well. So that's the like first phase of BLE. And that one thing that you can do in that advertisement is that you can also say you can connect to me. And then once you can connect, you have higher security and you're specifically connected to another device. And so I think it's kind of the go-to way of doing this because of that advertising phase, which there's kind of two acronyms you'll see. There's GAP, G-A-P, and there's GAT, G-A-T-T. GAP is like that first phase of like, how do you discover who's out there and how do you connect? And then GAT is like, once you're connected, how do you discover what you can do by talking to the other device? Mark Olson says, we need a new chart that's got power consumption axis and maybe a fourth axis for costs. Let's see. Would you recommend your key finding thing, or best is to take a itsy bitsy NR52 a LiPo reinvent the wheel? If you need something to find stuff, just do the tile. Just get a tile. They've like cost optimized it a lot, and power optimized. Okay, so BLE I think is the best solution for connecting a phone or a tablet to another device. I prefer like Wi-Fi is only good if you're in a particular location, and even then I think Wi-Fi is pretty bad about discovering like how to actually communicate to the two devices. Now that being said, one thing I've been looking at is like doing file transfer over BLE, and one thing that I found is that both I think AirDrop AirDrop and Android's equivalent of like share nearby, like those are both protocols, I think, where what they do is they use BLE to discover like if they're on the same Wi-Fi, and if so, they actually transfer the file over Wi-Fi. Good night, Sammy. Nice chatting with you. G3 Holiday says Happy Easter. Yeah, so Bluetooth is these two phases. And one thing that Daniel was talking about is that, you know, as you discover a device and then you connect and then you can upgrade that to a secure connection, one thing that you can do is once you've kind of connected securely, what you can do is you can also exchange information so you can reconnect automatically next time. And that's called bonding. So pairing is the process of establishing the secure connection. Bonding is figuring out how to save all that information so you could do it the next time. Yeah, so we have support for like Bluetooth HID, so keyboard and mouse. And I did this project called BroadcastNet, which is just like, it just uses that first phase of BLE to broadcast sensor readings out. But what we're going to talk today is more about, Ryan G says you can also use IPv6 over BLE for internet access. I haven't had much luck with it though. Interesting. I hadn't thought about that. But that does help a bit. Okay, I'm getting hot. Let me open the window before I keep going. Look at that cute kitty. So there's this idea that I have for BLE workflow. And this is the thing that's very, very interesting to me. The idea being that you should be able to use CircuitPython from your phone or a tablet without a computer ever. And so what you want to do is there's multiple components of that, but that's kind of like, oh, you can't see the cute kitty. Here's the cat cam. He's not sound asleep though. Because he woke up when I opened the window. All right, there's some cat for you. And I guess I'm not showing anything on the desktop. Just remind me to go back to it. So this is comparable to what I consider the USB workflow, which is what the only workflow we have for CircuitPython is right now. But BLE is really interesting because one, it enables some devices that don't have native USB, and two, it enables people to use from their phone and tablet, which more people have phones and tablets than they have desktop or laptop computers. So like the audience for CircuitPython from a phone or a tablet is much, much larger than otherwise. So it's really important. And it's been one of the things that's been like on my mind to do. But now's the time. So Trevor, who Adafruit pays for iOS development as well, is now working with me. So he's doing the iOS side. We've had some meetings this week, and hopefully next week we'll have something to show. But I'll show you what I've been doing kind of on the CircuitPython side to start. Luca says, Bluetooth workflow, interesting idea. Yes, Gareth says, so file transfer isn't super simple. So turns out there's no standard BLE file transfer protocol to the degree that like you could find an app existing on the store that would do it for you. The things that you would think of like AirDrop and Share Nearby are things that are proprietary to those manufacturers, and they use Wi-Fi as well, largely because Wi-Fi is going to be way faster. G3 Holiday says, I know you can send data with the microbit BLE, but Can you program it for mobile through BLE? I think there is a way, but you have to have some software on it already. Microdev says, "Did you consider a web app?" Yeah, I think I'm kind of focusing on the mobile side because the desktop side it should be kind of fine as well. David G says serial UART over BLE is not super standard as opposed to serial on Bluetooth. There's a CircuitPython lib that does the Nordic way, but you cannot change the UUID for another copy of serial. Yeah, so I think I would call the Nordic UART service a standard. I've seen other people use it. Like I think the Esprino people use it. So even though it's not a standard from the Bluetooth SIG, I think it is kind of a standard. So let's talk about the pieces of what I consider a BLE workflow. So there's the two parts of BLE, the discovery, and then once you're connected, what do you do? So there's one part that I want to do that I neglected kind of in my first pass of this a couple of years ago, which is like, if you have multiple CircuitPython devices or Adafruit BLE devices or BLE devices, how do you pick which one that you want to interact with? How do you make sure that when you're pairing, when you're connecting to it, that you're the person that's connecting and no one else is trying to kind of sneak in and connect out from under you? So there's this like discovery and pairing process. And so what I'm envisioning for that right now, and we're experimenting with this and it's all early, but the idea is that makery devices that have Bluetooth will broadcast. So at the very start, they'll broadcast an ID that is specific to the type of board. So like the classic Bluetooth way of doing this is just like a list of names, right? Just text. And I think that's terrible. So what I want to do is I want to advertise an identifier that says I'm a Circuit Playground Bluefruit, or I'm a Feather NRF 52840 Express. So that's the first step. So what you would get is, instead of a list of names, you get a grid of devices. And then one thing that we're thinking about doing is each device would be doing something different to distinguish them. So in case you have two Circuit Playground Bluefruits, the like NeoPixel animation and the song they're beeping out or something would be different for each of them. And you would be able to see that on the on like a grid of devices that you've discovered. Could you discover with BLE and drop down to serial over Bluetooth for transfer? Yeah, we'll get there. Yeah, Microdev says you can also add a unique ID to a name. We do that already. If you've used CircuitPython already with BLE, you'll see it's CircuitPy and then 4 letters. So they are unique, but the 4 letters don't really tell you anything. And I think it is possible to change as well. Okay, so there's 3 major parts that I can think of, and that's the first piece is how do you discover which device you're talking about? And once you know what you're doing, how do you make sure that you're the person that connects to it? And there's things like you don't want it to always be connectable, because once you're connected, that's kind of like a special relationship or something, right? Like it's only in certain cases where you actually want to go back to that, like, okay, I want something else to connect to me. So there's a lot of trickiness there around, like in CircuitPython, we'll have kind of like it always working, always going, but then like if user code's trying to use BLE as well, how do you share with that? So there's a lot of details to get there. But then the workflow side of that is once you're connected. So imagine we're connected and we've solved all that. And in fact, all that thing that we've solved is like not specific to CircuitPython. Like that's stuff that we could have work for something, a board that's running Arduino BLE or whatever BLE, right? Like that doesn't have to be CircuitPython specific. Also, there's like 2 components to a CircuitPython workflow, and there's reading and writing files, and then there's also the serial output for seeing error messages and doing the REPL if you want to. So those are the 3 pieces. There's the discovery and bonding, and then there's the file transfer stuff and the serial connection stuff. the serial connection stuff is pretty straightforward in the sense that the Nordic UART service is pretty standard. The problem is that it's likely that the user code may want to do that as well. So then you have this problem we have with USB, like how do you have two serial connections going at once? And it's not entirely clear how to do that. Furthermore, in the internals of CircuitPython, we've got to start to figure out like how do we swap out different serial connections in the like at that layer? Because right now we're like pretty closely tied to tiny USB, but you could imagine both different forms of output, like a display, but also different forms of input. Like maybe if we have in the future when we have USB host, like how would you get just characters in from a keyboard, for example? So there's a lot of kind of rethinking we could do internally to make that make a good interface boundary for serial inputs and outputs, like text inputs and outputs. Daniel asks, for devices that allow multiple devices to connect, like a mouse that toggles between machines, do you need a separate BLE chip for each device? No. What you need is what you'll find in at least on these Nordic chips for CircuitPython, there's a define that says how many concurrent connections you can have at once. It just like sets aside memory for the maximum number of connections. And right now we have CircuitPython set to 2. So if we have this one that's to your phone, you may just want to use that one. You can get things like the current time. You can get notifications over that link. But then also if you have a second one, you'd be able to connect to that as well. You don't need separate chips as long as they have enough RAM and resources to do it. Keith E says, is this workflow tied to BLE or is it standard for regular older Bluetooth as well? This is all BLE, Bluetooth Low Energy only. It is not regular Bluetooth. What you'll find is that like BLE is kind of becoming the thing, I think, except for audio. And even BLE 5.0, they announced audio over BLE instead of regular Bluetooth. So I think the future is Bluetooth Low Energy. So we're not doing that. So Gordy G asks, the number of pairs, bonds, or connected. So I was referring to the number of currently connected things. There are separate settings for the number of bonds that you can store at the same time. But yeah, this is Bluetooth only, or this is BLE only. Sorry. And for example, the upcoming ESP32 S3, like the S3 is BLE only. It doesn't support classic Bluetooth. Oh no. My monitor turned off. I'm having a bad video day today. Right, so David G says, I was successful in connecting to 2 separate computers simultaneously pretending to be a mouse. Right, so once you're connected, typically the code underneath will stop advertising. So advertising, you say, hey, I'm this name, I'm this device, and I have these things that you can do with me, like different services I provide, and I'm connectable. And then once something connects, like it usually automatically stops. But if you wanted to have a second connection, so there's a lot of terminology. There's a lot of terminology in Bluetooth land. And it's important to know that like, because you have these 2 sections, there's GAP and GAT. So device discovery and connection, and then service use and connection in GAT land. I should just do it that way. In the GAP world where you're connecting, there's 2 terms that you need to know. One is client and one is peripheral. So client is the device that initiates the connection to the peripheral. Did I say client? That's wrong. It's central. It's central, not peripheral. It's central and peripheral. Connected. No data. Am I back? Am I back? Am I back? Am I back? What is going on today? I'm back, right? Okay, thank you, Bruce. That was so weird. Ugh. I don't know. Like, I did get a notification from OBS this time. You all are awesome. Sorry. I didn't mean, I should not say guys. It's not just guys watching. You all are awesome. Gordy says, I want to make a BLE keyboard that I can quickly switch between my phone, desktop, laptop, and Raspberry Pi. So what's the most bonds possible? It depends. Don't say the word. Not peripheral, but that was what was the problem. Yeah, I think it was only a few seconds. Yeah, folks. I like folks or all. We peeps. Okay. Yeah, so there's central and peripheral. And then on the GAT side, there's client and server. And then there's this notion of services. But once you're connected, each side has services. So for example, my phone is the central. It connects to a Circuit Playground Bluefruit. Once they're connected, both sides have services. For example, my iPhone has a current time service that can give you time. It also has like a Apple notification center service. So that tells you when you get texts and stuff. So those are services on your phone. And then you have services on the Bluetooth device, like a Circuit Playground, which would be like your file transfer service, your REPL service, that sort of thing. And those are servers on each side, and the person talking to the server is a client. So there's like all this terminology around BLE, which is like, it's very confusing. It took me ages to wrap my head around it. Jen says, what security things should we be aware of when working with BLE? I'm a bad person to ask. Generally, I from what I've seen, BLE is kind of like not super secure ever. I was looking at this a little bit earlier, trying to figure out what we'll do with CircuitPython. But you've probably seen the ways that you try to connect. Is that you have this problem that like, how do you know what you're talking to is the right thing? And so you'll see things like one side or the other can give you a number, and then you type the number on the other side, for example, to confirm that the two things that you think are connecting. There's also a mode where you can have both sides display a number and then just say, yes, they're the same. But there's also just like, you can encrypt all the way up you want without any sort of confirmation. And as long as you do that part in a secure area, like nobody's near you that's going to sneak in and listen to that communication, like from then on, you could kind of like assume that it's okay. Foamy Guy says it works well unless all manufacturers hard code it to 1234 or 0000 to make it easier to connect. Yeah, I think once early in BLE land, manufacturers had to do that, but they kind of realized that like they have this what they call just works pairing, which is like hides all the numbers from you and just assumes that it's correct. But it still allows you to establish like all of the cryptography so that the connection going forward is okay. Gwiz says there was a microcontroller that used flashing an LED in your phone camera to pass pairing information. Yeah, I was thinking about doing something like that. I think the reality is, I think on the device side, we can control when we accept a pairing. So we could just wait until it gets, like you just press a button to say like, yeah, I do want to pair. And the nice thing is that you can talk over that connection before you're paired. So one thing I was thinking is what would happen is you would connect. So the first thing is picking out of a set of devices that look the same, pick the one that looks correct. So they're doing different things. So you pick the one that you're talking about, and then once that initiates a connection, and that connection then means that both sides change their animations, and they should be changed to the same thing. And then once you do that, you can do another thing of confirm that you want to connect or that you want to pair. Yeah, Bruce S points out that NFC is another system for pairing. That's known in the Nordic docs as out of band, which is like having a separate system for sharing the cryptography secrets. Betagraph says, we had a flash the CRT thing back in the day. Emmett Ray asks, could you recommend a C and C++ GUI API for Linux, not Qt, FLTK, or GTK? I don't have any recommendations. I think the most popular thing is people are using like the Electron stuff, like the Chrome web stuff, because most modern GUI folks are web people. So it's a huge download, but that's, I think, where GUI really is in the web. But yeah, I'm not a great person to ask for that. Okay, so let me switch back to the desktop, and I'll answer questions again. But let's talk about where I'm at, because at some point maybe Lady Ada will call us. So first off, I fixed a couple bugs, so let's just go over those. So if we look at closed pull requests, so let's see, here's one. So 2 small packet buffer fixes. So packet buffer is a native class in CircuitPython, and what it does is it queues up, it has both transmission buffers and receive buffers, but it remembers the packet boundaries that came in from the lower BLE layers. And so that's what packet buffer does. And I found a couple problems. One was that if you're the client of a packet buffer, it wasn't detecting when you disconnected. So it would just, like, if you were trying to read from it or write to it, it wouldn't realize that it was disconnected and wouldn't stop trying, which is really annoying because, like, it gets out of sync. And then the other thing was, if it is trying to write, so there's this loop here where it's in buffer write. I know that's probably hard to read. But it says, like, oh, while there's not enough room, and we're valid, like, just wait until there's enough room. And this is supposed to handle the disconnect, but it was broken, so it wasn't working. And I realized that sometimes we have loops that you can't break out of by Control-Cing. So this allows you, this MP-hal is interrupted, allows us to also exit this loop when you Control-C it. So if you've ever been using CircuitPython and have not been able to Control-C, that's usually because you're in some sort of a loop that is not checking this. Gordy asks, don't the packets have sequence numbers? They may have sequence numbers at the BLE layers, but we don't get those. We don't get those at the CircuitPython layer. If you're thinking of BroadcastNet, I added sequence numbers there as well. But that's all just advertising. Packet buffer is for when you have a connection. Okay, so that's one of the 2 sets of fixes. And then where's this other one that I did? Fix central pairing. Oh, so yes, you can't. We weren't able to pair from a CircuitPython device, and this has been like a while that this has been a problem. And the reason is like we talked about the number of connections you can do. There's these configuration settings for the Nordic soft device, which is like this chunk of code that they give you that you can't read, which is terrible. But there is this setting for the number of pairing processes you can do concurrently. and we were inadvertently setting that to 0, which meant from CircuitPython, we could not initiate a pairing process to another device as a central. So I fixed that because what my setup is here, I have a Circuit Playground Bluefruit. I don't have my overhead set up today. I have a Circuit Playground Bluefruit, and I have a Feather NRF52840 Express, and they're talking to each other. And one has to pair with the other. And that wasn't working, so I fixed that. I added a debug. And I also fixed this issue where we were crashing. We were actually doing... there's a deep dive from somebody else into Bluetooth LE security. Which is good. We're not quite there yet. So there was a crash here that was happening because remote service list was null, and it was calling this list clear, and it was doing stuff with that null pointer. It was bad news. So I found that there was like an assert that I only turned on when I was doing a debug build that it found. So I fixed that, and then this error no memory is which I think this is what Johnny changed. So it's my fault. But this was the error code that we were returning when trying to pair but not having enough space. So that's the stuff I fixed so far. And then the next step for me, so a lot of what I was doing this week was trying to kind of like get proof of concept code into CircuitPython that was behaving the way that CircuitPython natively will behave in the future, so that Trevor can be unblocked and start working on the iOS side. All of what I've been working on right now is like CircuitPython library stuff with example code, and then running that example code on a device will make that device act like CircuitPython will natively in the future. Bruce S says, I noticed the 7.0 tag has appeared in the CircuitPython repo. Wonder what that will bring. So yes, we had a 7.0 alpha 0 tagged. And the reason to do that tag is that all of the nightly builds or the per commit builds now will say that there's 7. And that unblocks us. That allows us to merge in stuff that will break APIs. So if you've ever looked in the 7.0 milestone, there's stuff in there that we only want to do on a major version boundary. One of those things, and the things that has a PR that may or may not have been merged, is switching how we do microlab. We had microlab split apart into a lot of small things, thinking that we were going to include parts of it, but in practice we've never done that. So by allowing microlab to be kind of one monolithic thing, it allows it to be more numpy compatible, and that's kind of what Zoltan V923Z wanted to do upstream anyway. But because that's a pretty big change, we wanted to do it on a major version boundary. So by tagging 7.0, that frees us to do things that we didn't want to do before. And so everything on main now is considered 7.0. We have a 6.2x branch, and that is that will be where we have like some stable releases for a while. And thank you to Dan for doing all that stuff. So David G says, so it is not going to be in the kernel, but in a library, or is it a mockup in userland? Yeah, it's better to think of it as a mockup in userland. But the benefit of starting with the library side is that you'll then be able to use other CircuitPython devices to talk to it, both when it's implemented in userland and when it's implemented in the kernel. So let me show you what I'm talking about. Ask Patrick W says, break stuff. Oh, it's not just creation, it's BLE creation. So as anyone knows who's done CircuitPython, we always have this issue of giving out USB product numbers. So there's there's vendor IDs and product IDs. And with Bluetooth, with the BLE workflow, we still want that ability of identifying devices based on a number. But not all of the devices that we'll want to do that with are have native USB. So they won't actually have USB vendor ID and product IDs. So I came up with this idea of creation IDs. And if you actually look, I've snagged creation ID at GitHub, and there's a creators repo. So can open the land rush. But basically what I'm doing is it's a 32-bit number for creator and then 32-bit number for creation. And so these are IDs that you can use to identify anything. I actually came up with this idea when I was doing that like FPGA system on a chip stuff. But it's just really general. It's just like, if you need to identify a creation digitally, this is how you can do it. It's two 32-bit numbers. The one thing that you need to standardize on is the creator ID. And then it's up to the creator to dictate how they dole out the creation IDs. And furthermore, what I've said is just like, if it starts with 4 zeros, it's just the USB vendor ID. So this is what we're broadcasting at that very start for saying like, I'm this device, is that we're actually technically broadcasting the USB ID, but there's space within those numbers for non-USB identifiers as well. So the way that is done, Hugo's shocked that there's no ADF for Adafruit vendor IDs. It's just easier. It's just easier to maintain and use the existing one. It's just a number. If you look at some of the other IDs we do, 32 bits. You think people are going to have fewer than 2 million BLE devices in the near future? Well, so USB vendor ID and product ID are only 16-bit apiece. And worst case, we allocate multiple creator IDs to somebody. Okay, so what this BLE creation library is doing is it defines the advertisement that happens. So I went pretty wild with all this BLE stuff when I did it a couple of years ago. A lot of the BLE data structures or classes are like very meant to be declarative, meaning that they're classes that declare the fields, and then you can use those classes in different ways. So like advertisements are both, Gareth says plus instance ID. No, I don't have any. I haven't figured out the per instance stuff yet. We might do that later. Maybe that's the right place to put it. But I was also thinking about doing like how to figure out what animations you're doing separately. We'll get there. This is all subject to change. I just created this week. So an advertisement object is used in two ways, right? It's I want to advertise this advertisement, or I was listening and I heard this advertisement. And so what you have here is you have match prefixes, which is a thing that says, out of all the advertisements you're hearing, if there's a prefix of this, then it's one of mine. And if that happens, it gets called with it gets called with entry. Let me make it a bit bigger. So if you're in this, like, I'm scanning, this object will be called with entry here. And then this is not right. I need to update this. It should pass entry into here. And then if entry is set, return. That's a bug. Love how I find bugs on this. Otherwise, if there's no entry, this sets default values. And you can provide services as well. So you provide that creation ID, but you also provide any services you want to advertise. For example, the file transfer service might be the thing that you want to advertise. And then at the bottom, we just have, like, just for right now, we have this mapping between CircuitPython board names and the IDs that we want to broadcast. This just makes it easy for our examples to pick which IDs to use. And then last up, there's this manufacturer data field. This is a standard kind of like BLE advertising defined thing. And Adafruit has a company ID that's been kind of given out by the Bluetooth SIG. And so within the Adafruit manufacturing ID stuff, we pack in this. I was calling it device friend. So this I need to update this as well. But here, this is the struct format for Python. So you can see it's two 32-bit numbers, which is what unsigned 32-bit numbers, which is what capital I is. And so that's how it gets set into the manufacturer data field, is that this is a data descriptor. So it says like there is this data in this class. And then when you set or get from creation ID, it actually calls a dunder get dunder set. I think the best way to describe it for folks new to Python is that if you've ever done properties, so you say like at property of this, and then you can say at name of property dot setter above the setter, you kind of understand that like you can mask the fact that you're calling functions under the hood. And then they're like the one level beyond that is that imagine you had two properties, but the contents of the functions are the same except for the name. So data descriptors are the thing that allow you to like factor that out and share the functions there as well. So it's like, it's very advanced Python, but it means that you can write the Python in the way of just saying like, there's this property here and it's of this type, and that dictates how it works under the hood. So all of these advertising data descriptors, what they do is they like pack and unpack the data into the like actual byte structure or an intermediate structure that can get converted to the actual bytes that are transmitted for the advertisement. But yeah, it's not simple. It's weird. I'm like still kind of like, I wish it was simpler, but at the same time, I do think it's simple. It's a little weird. Okay, so that's creation ID. This is just like for the demo for Trevor being able to have a grid of different different models of different boards that are advertising at the same time. Any questions about that? Oh, Mark says, creator IDs, how are you allocating them? So 1234XXX could be registered by one person / organization. No, I'm thinking like you would have to have an exact number. You wouldn't be able to set a like mask like that for creators. The only time I'm thinking of doing stuff like that is if you want to like subsume other ID spaces, right? Like USB. So like USB, you have 16-bit vendor IDs. So if you have a 16-bit prefix, that allows you to kind of like interoperate with an existing ID space. But the intention is for creators. Yeah, the intention is that creators would not have kind of numeric space in that 32 bits. Creators themselves would not. Okay, so that's one thing. The other thing, well, actually, let me show the examples first. So example-wise, there's two examples. There's advertise, which is, this determines what the creation ID is based on the uname machine. And then it just constructs the advertisement, prints it out so I can see what it is, and then just advertises it for 2 minutes. So that's one side of the testing, and the other side of the testing is this, which is you scan. And so what you say is, I want to start a scan, and I'm looking for these particular types with this interval, and this is kind of a reverse lookup for taking a creation ID and figuring out what string it is. So this will tell you like, oh, I saw a circuit breaker on Bluefruit, for example. So that's the simpler of the two things I'm working on. And so the other thing I've been working on is file transfer, which is probably the more exciting piece. If you've ever wanted to do with BLE, there's not really a standard way of doing this. So I think we can be the people that kind of like put a line in the sand and publicly kind of say like, there's no official way. There's a BLE object transfer service. There is this thing called object transfer service as defined by the spec, but I can't find any apps that support it. I looked at it and it's complicated. And there's like some examples from Nordic, but they say that they're not, they don't actually fully match the spec. So like this might come in the future, but for now, like I think there's space for just like, I just needed to move a file over. It doesn't need to be optimal. One thing that makes the object transfer service more tricky is that it uses L2 cap channels, which are like a lower level of the BLE protocol. The advantages is that it would make it faster, but the disadvantage was that up until recently, I think, like Android and iOS didn't necessarily expose that to applications. Okay. So I'm making my own because I enjoyed designing stuff. So I had this library called Adafruit CircuitPython BLE file transfer. Patrick says the BLE SIG is in Kirkland. If you want to chat with them, I might have some contacts. I'd rather just, you know, make my own standard. David says there is/was that file transfer solution over the REPL for MicroPython. Can you reuse that? I haven't looked super closely at it. Generally, I don't like that there is a I generally don't like that there's a this weird world of like switching between like machine access and user access for the REPL. I'd much rather have it on two different serial connections. But you're right to think that like essentially it's just a protocol over a serial link, and you'll see that that is what I'm doing. And I have had discussion with Damien. Like Damien was thinking about this place of like this world where like there's a standard serial protocol, and like all of these other ways of transporting have like standard, like essentially are serial links to some degree. So like by just having one standard serial protocol for file stuff, like you could then do Wi-Fi or whatever as well. I'm not ruling that out. But I didn't look too much into how they do it over the REPL existing. If you have links, send them my way. I'll tell you what I have. Foamy Guy says, do you envision the BLE file transfer protocol requiring the storage to be mounted writable from boot.py on the CircuitPython device? That's a great question. For those of you who are like relatively new to CircuitPython, we have this thing where if you are on USB, we don't want you to write the device from CircuitPython at the same time. And that's unfortunate. Like the USB protocol for changing files is below the file system, meaning it's writing blocks. And so you can't really have two things manipulating the file system data structures at the same time, because they're not going to be consistent. So I think the easy answer is for devices that are BLE only, not USB, like obviously we would just have them writable from CircuitPython and from BLE at the same time. How we actually want to walk the line of like it's a USB device as well is going to be trickier, and we're just going to have to try it out. But I think there is a world where we can make it a bit more dynamic. So I don't know. Ampy is not a good protocol. Ampy does things like switching it into raw mode and then like calling some. No, I don't like it. Patrick says this might be old information, but at one point iOS didn't support serial over Bluetooth. Has that changed? So that might have been true for classic Bluetooth, but BLE is more generic. Because BLE operates at this like service level stuff. The one thing that you have to be aware of is that if the OS itself uses a service, you can get into tricky things. So like if you provide the HID service from a Circuit Playground Bluefruit, you're not going to be able to directly talk to that service from like your app, like because the iOS will use it out from under you. G3 Holiday asks, what is the BLE range on a Circuit Playground Bluefruit / microbit estimate? I've not experimented with it. I think it was pretty neat that when we first produced the Circuit Playground Bluefruit, like they were doing some phone to Playground communication that was like across the factory floor, so like 100 feet maybe. But that's line of sight, so it does change a lot with like what's in your way and how many Wi-Fi access points you have and things like that. So I don't know. I've been trying to set up like broadcast net stuff around the house here and have been having some trouble just like from our bedroom that way to into this room. So it varies a lot. So no promises. Okay, so let me show what I have. And one thing I was thinking is I could write the README. I haven't written any of this stuff yet. Hugo says there was a video of over 50 feet connection. Yeah, 100 might have been too much. Gordy asks, does BLE keyboard use scan codes or ASCII? So BLE keyboard actually uses the same HID protocol as USB. So I think it's scan codes. It's the same as USB. They just like, the BLE spec says, here's how you translate from this spec into BLE land, and then look at the USB spec, which is kind of interesting. One advantage of this file transfer stuff is that it operates above the file system layer. So we would be able to do like CircuitPython writes and BLE writes at the same time because it's above the file system. Like CircuitPython could manage the file system all on its own. David's asking about what would be acceptable BLE bundle stuff, and we'll cross that bridge when we get to it. But I think it would be okay. Okay, so let me show you what I got. Obviously, I've just been doing this, so it's all subject to change, and it's all not well documented. But what I have here is there's an Adafruit BLE file transfer library, and so it has two characteristics. This is like the vendor ID base, which is file. Oh, there should be an R in there. It's the word file transfer. I did find this cool Nordic Bluetooth numbers database, which I think is used by the NRF Connect app. So this will be really handy for like recognizing UUIDs. They're supposed to be random, and they really should, but I don't make them random. I got it from the Sphero people. The Sphero people don't have a truly random number. Okay, so there's a transfer characteristic. It allows you to read, notify, and write no response with a maximum length of 512. And to talk to it, you have to be encrypted with no man in the middle stuff. So that means that there is a pairing process involved. And it uses, when you're using it from CircuitPython, it uses packet buffer to buffer the packets going each way. So the file transfer service has a UUID of FEBB, which is, and no, it's not pseudo-random. It's a word, but it's random. I randomly thought of it. So standard UID is actually a short one that we have for Adafruit that we've never used. So I think this is if we do it decently enough, meaning we document it well enough. I wouldn't be surprised if other people used it, especially if we have like, I think the app that Trevor's working on now is going to be just kind of like a standard file transfer app. And so that will work with CircuitPython, but it could work with anything else. And that may be why people like pick this up on other devices as well. So file transfer service, you have a version number, which I have yet to actually set, but that version numbers should always be included, in my opinion, because it gives you the freedom to say like, oh, we learned what our mistakes were. We're going to make a version 2 or 3 or 10 or 20. And the code that's on the other side can actually detect what version it is and adjust accordingly. You probably don't want to support all versions, but at least you can support some versions. And if you don't support something, you can say we don't support it. So file transfer service, there's a version characteristic, which is super simple. And then there's this transfer characteristic, which kind of, to David's point, acts as a serial link. Although it's using the packet buffer, which is like maintaining the notion of like how long the packets were, which I'm actually kind of undoing. So in terms of what actions I think you need to be able to do over that, you can read, you can write, and you can delete. And then you can also make a directory and list a directory. Gordy says, I am going to need a way for my keyboard to know whether the device it's talking to is in Dvorak or US mode. You may want to think about it in the reverse, which is just having having your keyboard just remember which device is which, because you can know what you're talking to. So 2 response codes and error no file as well. I'm going to play around with this error stuff a little bit more. But what I've been trying to do is implement these 5 actions, because I think this is all the actions you need for like very basic file transfer stuff. So reading and writing a file, deleting a file. You could also delete a folder. You can make a directory, and you can list a directory. So I think those are the 5 things you need to do. And this is the client. So this is like I'm talking to the file transfer service. How do I get a file across? I've got, oh, Hugo found the video. So what this is doing is it's just there is a notion of like how big the packets are that can be sent at one time. So you can so this just splits a larger buffer into the chunk sizes that you can send, because packet buffer will tell you if you're too big. Read into, this just reads as much as it can, or it reads until it gets a non-zero thing. And then this is handling the value error. If you give it a buffer that's not long enough for what was received, that's probably a protocol error. So I just have it like try again with a bigger packet and print it out to tell me that I got it wrong. So for reading, what you do is we encode the path to UTF-8 because, you know, UTF-8 is the way to go. Right now, what we're doing is one of the main things I wanted to do with this protocol is handle control flow. And what I mean by that is imagine that you're a Circuit Playground Bluefruit, and somebody's trying to write a wave file that's like a megabyte large. And what you're going to do is you're going to be able to write like 512 bytes or 4 kilobytes of data to the flash, and then you're going to have to erase, and erasing is slow. And what you don't want to have a 1 megabyte buffer. You can't, because your RAM's not that big. So you need this process of saying like, okay, give me the next chunk, give me the next chunk, give me the next chunk. And so that's what you'll see here. A lot of what I'm doing is saying like upfront, if I'm reading a file, tell me like how big it is. Or when I say I want to read this file, I can tell you I can handle this much of the file to start. And then I can tell you as I can deal with that. And then the reverse is true. So when you write the thing you're writing to, it will tell you how much space it has to write. The downside of that is that you will be slower because you're waiting to hear kind of confirmation back. But the devices on both ends can decide how much memory they want to set aside to buffer. The larger it is, the less you have to confirm with each other, the more you can just haphazardly write out. Okay, so this is how read works. Actually, maybe I shouldn't go through there. If you want to take a look, I do kind of have it working. Let me show you how I'm testing it. So I did restart, so I'm gonna have to get it going again. But let me J-link it up. Mark, are you domain squatting? Oh, debug edge. Nice. Okay, so J-link, and then... So I'm going to just get the NRF52840 feather going underneath GDB, because there's this nasty USB bug I'm finding that I want to see if I can catch. I'm finding a bug where it like starts corrupting the file system, and it's bad news. So I'm going to get that going. So you can't see it, but I got 2 devices popped up that are connected. I have a CPB and a feather, and I renamed the file system so I can know. David says, in Bluefruit Connect, you have a packet-based protocol over a serial with a function like picking a color, sending an image. You could expand that. I don't want to expand that. I think that's... I know what you're talking about. That's for the Bluefruit Connect app. It's not... I don't think it's in the spirit of Bluefruit to do it Bluetooth to do it that way. I think it's important to still have capability discovery at the level of services, and that's because advertising has these things that say these are the services I provide. There's also a way in BLE to say I'm looking for a device that has this service, so soliciting a service. So it's important to, like, even if I have a serial protocol, it's important to kind of only like narrowly define what I do over that protocol so that I can advertise kind of like, in general, I can do file transfer. The Bluefruit Connect stuff is like, I think it literally is like I advertise as a Nordic UART service, which is a bad idea. Like, even if it acted like a Nordic UART service, it should be called something else, because it's assuming a protocol on top of that. Hugo says, is the bug that you're starting to corrupt the file system but not finishing the job, or that it's corrupting the file system at all? Asking for someone who's pedantic about the English language. Is the bug that's starting there but not finishing the job? It's that it's corrupting it at all. Yeah, so David G says, maybe that Bluefruit Connect and protocol and serial was there for old ways to connect serial coprocessors to old stuff before NRF52 support. I think you're almost right. I think if I remember right, the reason that they did it was like the early NRF51 boards. They could only have very limited numbers of services that it was like managing at the same time. And I think that's why. Okay, let's see this in action. It should be going. So I'm using TO because TO is awesome. It's a terminal program that auto reconnects. So let's just see. I have BLE logging turned on, so you'll see it like spewing BLE event stuff. And you can see that on this side it disconnected. So this side is trying to reconnect. You can see it scanning for advertisements. And there's a bug here about disconnect. So I'll just Control C and Control D. So it does some events. And so what you can see here is it wrote to this file. It does it every 10 seconds, so it's but it's, let's look at the example code first. So in this repo, there's examples and there's two things. There's and these are the two things I'm running on each side. So there's simple test and there's stub server. So simple test is the code that is trying to do some file system operations. So this is like all this ugly boilerplate for BLE that I wish I could figure out how to get rid of. But it's all about like reconnecting. So you can see there's this like while true, try, and then while connected, do these things. And then for every connection that you have, if there's a file transfer service, try to do this stuff. Gordy asks, is TO available on Linux? Yes, I'm on Linux. I'm using TO. I'm on Arch. So yes, it is available. Okay, so there's the echo. So this is how you get the service that the thing you're talking to has. And then we make a client for that service. And what we're trying to do is we're trying to write hello.txt, hello world. We're trying to read it back and then print it out. We're trying to make a directory world. We're trying to list it. It should be empty. And then we're trying to make hello.txt within world with hi world. And then we're going to list it again. So that's what I'm trying to do. And I'm pretty close. I have a bug right now. That looks right. Well, the list is not working. So it's not perfect. G3 Holiday says, I thought you were on Linux. Are you on a Raspberry Pi 400? No. Raspberry Pis are so slow. I'm spoiled though. I got one of the newer Ryzens, so I can compile real quick. I'm on like the 16. I'm on the 16 core Ryzen, so it's a lot speedier than a Raspberry Pi 400. I did build CircuitPython on a Raspberry Pi 4, and it took, I don't know, 2 minutes from the start, whereas this computer can do it in like 20 seconds. So it's pretty wild. So here's the bug I have. I'm not writing the file right. Although I'm also not reading back the hello dot file name. So it's not quite working. It's been pretty good. this has been a really good process to figure out what the right protocol is by doing it in CircuitPython lands, because it's gotten me thinking about like the request is kind of a unique format, but then the response can be kind of a standard format. And that's one thing, like in the list directory, I'm like returning each entry, but I also choose to return an entry afterwards. And each entry that I'm returning has like the total count of entries and the current index of it. Oh, something just crashed. It like disconnected and reconnected for some reason, but it wasn't though. It was the other one. G Holiday says, I don't have a Raspberry Pi 400, so I wondered if they were faster than a Raspberry Pi 4's turtle speed. Bruce says, I think my Intel laptop builds in about 90 seconds. Yeah. Yeah, so I'm really close. What I'm doing internally is, if we look at the other side of this example, this stub server, I'm actually storing just the data in this dictionary. I'm just storing it in RAM. I'm not actually doing any file system writes because this file is on the file system and I don't want to mess it up. So all I'm doing is I'm kind of mirroring the file structure in just a nested set of Python dictionaries. I am able to write and read. I was working on list directory. I haven't done delete yet, but I had make directory as well. I have the Ryzen 5950X. It's awesome. Very happy with it. It's expensive, but I'm very happy with it. Yeah, so the cool thing about doing it this way also is, like I was saying earlier, like this stub server is the part that will be replaced with the internal version in CircuitPython. But the client, the file transfer client, is in the library, because then once it's native to CircuitPython, like another CircuitPython device, like a Blinka BLE device, could use that to connect to another CircuitPython device and write a file, which would be really cool. So that's where I'm at with it. I'm kind of like losing steam. Are there any more questions? We don't have any of the app side stuff done yet, but hope maybe next week we'll have the advertising stuff done. The next step for me is, like, once I kind of get this in a better place, I'll document it all. I'll write it all up, and then I'll start moving it into the CircuitPython core. Once we've kind of like demonstrated the protocols like reasonable. Sander says book recommendations for BLE. I do have this book that we carry. I think we carry it in the shop. It's pretty light. So getting started with Bluetooth Low Energy. One of the folks who wrote it is Kevin Townsend, who used to work with Adafruit. It's not that thorough, I guess. I think a lot of what I picked up is just from like reading the Nordic talks and just doing it. It's not like there's a really good USB book that I recommend, but I wouldn't kind of recommend it at the same degree. But that's a place to start. Mark says no Lady Ada. She didn't ping me. I could ping her, but she's busy. Maybe I should. But we were talking earlier, so she knows that I'm on. I'm not gonna bug her. She's busy. She's busy. David G says, Blinka server-side thing to control a Pi0. Is that possible, or we hit a limitation of BLE on the Blinka side? I'm not sure what you mean. So like the BLE IO Blinka can only act as a central. So it can only initiate connections. G3 Holiday recommends this Make Bluetooth Projects Raspberry Smartphone. Copy link. Let's take a look at that. Ah, interesting. Bluetooth LE projects for Arduino, Raspberry Pi, and smartphones. I have not looked at this book, but it comes recommended from G3 Holiday. Oh, to have the BLE workflow for a Pi. You could... I'm having such bad internet weather. The internet hates me today. It just reconnected again. I think I should be back. Before we get a bunch of... Yeah, you're back. You're back. I'm sorry, folks. It's just not the right day. Hugo says, you never left for me. Really? Because it waited like 4 seconds to reconnect. Patrick says global DNS was a mess yesterday. I mean, it shouldn't need to do any DNS stuff while I'm streaming. I think that's a sign that we should just call it a short day today. Thank you, Hugo. Hugo says, no matter how the internet feels about you, we still love you. Right? Yeah, I guess I don't feel like I have great Bluetooth resources. We tried to, like, when we did it before, we tried to capture a lot of it in Learn Guides. But there's a lot of protocol, kind of like a lot of stuff around it. It's interesting to think about like how you would simplify things. Like one thing that you're seeing with like more modern stuff is like exposing the L2 cap, which is like the link layer, like the lower level stuff. Like it's interesting that that's becoming like available in more APIs. It's kind of a sign that you didn't necessarily like all the structure of services and servers and stuff is like maybe not what you actually need. Yes. Bluetooth numbers database. Yeah, this is neat. I think they're BLE. So there's a number of examples, right? So like this is not the first time we've done Bluetooth. This is just like me circling back to Bluetooth. David says, any news about the convergence with BLE on MicroPython? No. I've been meaning to take a look at it. I heard really good things about MicroPython. Like they have an async Bluetooth. Part of the problem is though that they took this approach of being like really low level. This is generally what they do in MicroPython is that like they, for Bluetooth, they kind of, so Bluetooth in terms of like how it's implemented, there's this, and we talked briefly about this last week, like it's not uncommon for there to be a coprocessor. And so like the coprocessor is considered the controller. And then there's a host as well, which is like usually the like beefier processor that may be running like Linux or whatever. So there's this host, there's host stuff, and then there's controller stuff. And there's an interface between the two called the host controller interface, HCI. And I think that MicroPython's approach was basically like all the host stuff generally gets done in Python. Whereas what we've taken in CircuitPython was to do all the host stuff kind of under the hood as well. And the reason for that, part of it is that we wanted to be able to do like BLE workflow from within CircuitPython, not have to do it in Python. It also means that like we have this principle, right, of like doing timing sensitive stuff on your behalf under the hood. And so that's why we have things like packet buffer, which is like we do buffering for you on your behalf within everything. So yeah, I think I don't think it's going to happen. I think the MicroPython folks are doing interesting stuff. But yeah, I think it's just a different approach than what we're trying to do. Gordy says, I guess they're not big on hand holding. Yeah, I've been thinking a lot about this. I'm actually presenting next week at the Open Hardware Summit, and I'm doing a 15-minute talk, which means I have to spend a lot of time getting it ready. But it's about interface design, and one of the things I'm going to talk about is this notion of outside-in design. So think about what you need to do and like let that drive how you design things inwards. Whereas I would say that and you can see that in CircuitPython, for example, like all of our hardware APIs are structured around tasks or things that you want to get done. They're not structured based on how or what hardware you would use to get those things done. But MicroPython is very much the opposite. Like they kind of assume that people using MicroPython are starting from a knowledge of the structure of systems on a chip, of microcontrollers, and working their way out. They're assuming that, oh, you want BLE? Well, like the layer we'll give you is like very low level BLE. And so they a lot of degrees, I think, work inside out, where they look at a data sheet and they say, this timer can do all these things. I want to expose all those into Python, or here's all the things that BLE needs to be able to do based on the spec. So I'll expose all of those things out to Python. I would say that's inside out, and that is not the way that I work. And there's a couple of reasons for that. I think outside in is a better way to do it, because it forces you to think about how you're going to use things. So like Adafruit learn guides are the outside, right? Like when you're going to do something, think about what guides you're going to write, right? Like start from like, these are the things I need to be able to do. And then figure out, okay, here's the different APIs I need to do that. And we talked a bit about this today, right? It was like, we need advertising and connecting. We need serial. We need file transfer. And we've thought about all those pieces. And then from there, you say, like, I need those APIs, and then internally I can figure out how to implement them. If you start inside out, what you end up doing is you'll end up creating APIs for things that people don't need, for one. And for two, because you're trying to be faithful from that internal side, like you're potentially really limiting the portability of that API, because you're thinking about the specifics of one implementation, which means your API is going to be specific to that one implementation. You won't be able to take that API and swap in a different set of internals to do the same thing. And I really think like we've demonstrated the value of outside in and our hardware APIs that were designed that way, because it's allowed us to take it from platform to platform to platform, and including onto Linux. So Daniel says, easy for user means a lot of work for the developer. Thanks for thinking of us users, right? It's a trade-off as well. Like the trade-off is that there may be things that you can't do easily in CircuitPython that you can do, in something like MicroPython, where they give you all the tools. Hi, the Tinkerer. So DCD link to the schedule. Abstraction. Right? G3 Holiday asks, is the Open Hardware Summit on YouTube? I don't know. I don't know where it will be. It's going to be a short talk. Like, I have a 15-minute time slot. So I am planning on streaming next week. It's like in the morning for me. So if it turns out that like, I assume they're going to post it, and I hope they post it as a separate video. But I could also just give it again on my stream later. Like, that's also not a problem. It's going to be super short. I'll tell you that right now. And I just started, like, I've been brainstorming it, but I haven't actually started doing it. So that's one thing I'm going to do next week. Which is a segue, I guess. We're going to wrap up here. But DCD David did ask kind of what's the plan for the next few weeks. DCD says, sounds like you're already starting to practice on us already. It is true. Yeah, it's good to like start to formulate these ideas and make these arguments, right? So yeah, I've been thinking about it some. I think so I need to, my plan is, where is my, I have an outline. I think my plan is like, I only have 15 minutes, so it's got to be pretty concise. It's going to be, what do I mean by interface? And that's interesting for Open Hardware Summit because it's both like physical interfaces, electrical interfaces, and software interfaces. And then what are the benefits of a good interface? Abstraction, less like more decoupling, which means better interoperability. And I think I should give some examples of this. And then I think the three things I have in mind right now is like ways of doing good design would be outside in is the first one. Outside in thinking. If you're defining a new interface, be explicit. And I'll show some places where, like for feathers, we were not explicit enough. And then third, be strict. And this is kind of the like, when we're a subset of CPython, we're strictly a subset, and it allows us to port that way. So those are kind of the things I'm thinking about. Ryan says, MicroPython seems to be aiming to expose all the hardware to Python. CircuitPython aims to be a consistent framework. Yes. Yeah, I mean, that was the crux of the technical discussion I had with Damien about the hardware API, and he wanted the ability. He was okay sharing the per function code across ports, but he didn't want to share the structure of the objects of the modules themselves, because he always wanted to be able to slot other functions in to the same module, and I did not want to do that. As you know, like my philosophy is like different functionality is done at module boundaries. And that's the reason for that is that, it ensures that in Python, it ensures that you get an error early. Ask Patrick asks, so at 15 minutes, is it a shallow dive? Yeah. It's like almost, yeah, I don't know. It's like a shot of seawater or something. Like it hits you all at once. And should be very concentrated. G3 Holiday says, cool, I'll definitely be there on Friday next week for Deep Dive's birthday. Yeah. Maybe I'll make some cake. But yeah, so that's what I'm thinking about. So I have to do that. I think I've gotten to the point where Trevor's not blocked by me. So that's like the main thing. Any time that Trevor's blocked on me is like going to be my highest priority. But he's working on the like show the device that's being scanned right now. So I think for me, it's like further work on the file transfer stuff. And then probably I'll switch back to like maybe figure out the NeoPixel patterns for different devices, or I will move into the CircuitPython core and start reviving the file transfer stuff that's in there. And also doing the stuff around like, how do I get in pairing mode? So like right now, or as it was before, is like it would kind of just broadcast all the time, and that's a great way to get somebody who you don't want connected. So there's some work there to do as well. So it's not super crisp and clear what the next few weeks will be, but certainly finishing the file transfer API on the Python side is the first thing. Okay, I've done a lot of talking. So I'm going to wrap up. Thank you again, DCD David, for taking notes. I will have to go through and edit the video a little bit. Thank you all for hanging out and sticking with me through the issues I had at the start of the stream. I think the BLE workflow stuff is going to be very, very cool. And I think people will, once we have the app side, it'll start to be like, wow, that's really powerful. And next week will be on Friday at 2 p.m. Pacific. I'm in Seattle. If you want to support me, you can support me indirectly by supporting Adafruit by going to adafruit.com, purchasing some stuff. If there are any boards and stuff that you think might be interesting to have, I'd recommend snagging them now. I know Adafruit is feeling kind of the crunch in terms of chip availability. So keep that in mind for yourself as well. I know we have a lot of Circuit Playground Expresses. I have not heard about any of the other stuff, so be aware of that. Daniel says, will you do a separate live stream for your presentation? I think by default it will be on the Open Hardware Summit stuff, and they usually do post them, I think. But again, this is like totally new, being all virtual, so we'll see. Either I'll do it during my deep dive next week as a backup, or if it turns out like after a few days that they don't post it separately, what I'll do is I'll just do it again, like separately as well. That being said, I talk a lot about this stuff in the deep dive already, so there may not be much new in what I can say in 15 minutes. It just hopefully will be better said. Okay, so if you have thoughts and ideas around the creation ID stuff, about the file transfer protocol stuff, now's the time for feedback. So David says, or you can make a long version more than 15 minutes. Yeah, that's called deep dives. And oh, I just noticed Spook is, he was like, Dad, your cat cam's off, so I have to sit on the desk. Oh, wrong shoulder. He's right there. Watching the birds probably. Anyway, I'm gonna call it. My brain's gone. Thank you all so much. I will see you next week on Friday. And on Discord before that, you can join Discord by going to the URL adafru.it/discord. I will switch back, and the cat is now looking out the window again. So have a great weekend, everyone. I'll see you next week.